Okay, pre-calc. We are starting lesson 7.3 on sequences. We're going to start with some basic definitions. First of all, a sequence is any set of numbers in a specific order. Oh, I'm not drawing yet. There we go. Any set of numbers in a specific order. Each element in the set is called a term. We use a subscript to identify which term we are talking about. For example, A1 means the first term, A2 means the second term, etc. A to the n means the nth term. Two types of sequences: infinite sequences. Infinite sequences follow the same pattern forever. The same pattern forever. Finite sequences follow the same pattern for a fixed number of terms. All right, and we have a couple ways we can represent these sequences. One, we can have an explicit formula. An explicit formula gives the sequence as a function of the number of terms. So this explicit formula is going to look a lot just like an equation versus a recursive formula. And the recursive formula gives the first term and a function for finding subsequent terms based on the previous term. And when we talk about the previous term, we think of n minus 1 as the previous term. So for example, if A1 is 5 and A2 is 7 and A3 is 9, I could also call, so the term previous to A3 would be A2, and we would use A3 minus 1, which is that n minus 1, takes me to A2, which is 7. So the previous term of A3 would be A3 minus 1, which is A2, which is 7. So anyhow, that n minus 1, that's going to pop up. You're going to see it all the time, but it means the previous term. Okay. By the way, if I did A3 minus 2, so I'm going to the, two previous terms, that's the same as A1, which is 5. So you can, play around with that as we do these. You'll see that a little bit. Okay, example 1. Tell whether the given formula is explicit or recursive. Then find the next three terms of the sequence. Well, let's just look at both A and B. You can see that example B, you are told the first term is 57, and then you are told to find every subsequent term, A to the n, by looking at its previous term, the one in front of it. So if I'm looking at A to the 5, I look at A to the 5 minus 1, which is A to the 4 minus 5. So this is recursive. We are given the first term and a function for finding the subsequent terms based on the previous term. And this right here says previous term. And this is explicit. Explicit. There you go. Okay. That just looks like a bit of an equation, right? So let's let's find the next three terms of the sequence. So let's find A1. We don't know what that is. And so that would be 10 times 2 to the 1. N is 1 here, and that gives me 20. A to the 2 is 10 times 2. N is 2, so I put a 2 there, and I get 40. A to the 3 is 10 times 2 cubed, which is 80. And so my answer here would be 20, 40, 80. Those are the first three terms of the sequence. Then over here for recursive, I already know A to the 1 is 57. So what's A to 2 going to be? Well, it says look at the previous term and subtract 5. So the previous term is 57 minus 5 is 52. A to the 3, it says look, take the previous term, subtract 5. So the previous term now is 52 minus 5 is 47. A to the 4, previous term minus 5. The previous term is 47. Minus 5 is 42. And so then the next three terms would be 52, 47, 42. All right. Next, we have arithmetic sequences. Any sequence whose successive terms have a common difference. So this is going to be plus or minus. D is very important. You can see the D here. You can see that same D here. So you have to find your D value. Let's just do a little example here. Let's say I have this sequence of 1, 3, 5, ... Okay. You can, this one, you can just see you're adding 2 each time, right? Add 2. But technically to find, so we would say then D is 2. But to find D, what you want to do is you want to do the right term minus the left term. So in this case, we could do 5 minus 3 gives me D, which is 2. Or I could do 3 minus 1 also gives me D, which is 2. By the way, the D has to be the same for all those. It can't change. Another way to think of it is you can do, you could say D equals the newer term minus the older term. So 5 would be newer, 3 would be older. Another way is D equals the a to the n minus 1 minus a to the n minus 2. This is the previous term to this term, and so you take one term and you subtract the previous term to it. Any of those are good. This is the easiest, I would say. But anyhow, here's your formula. So when you're writing an explicit formula for an arithmetic sequence, this is what you go with. When you're writing a recursive formula, you go with this. Okay? And so we're going to do that here. Next page. Given the arithmetic sequence, -12, -1, 10, ... We need to do 3 things with that. Find the recursive formula, find a of 41, and find an explicit formula. So in order to find these formulas, or to find a 41, we have to find D. And so we're going to go D equals 10 minus a -1, which gives me 11. So that's my D. You can check it, do the next one. -1 minus a -12, that still gives me 11. So I'm happy, I got the same number. So I have my D value. All right, find the recursive formula. You can see it right here. That's the pattern we want to follow. So we want A1 is -12. You always, in a recursive formula, you tell me what A1 is. And then you're going to say AN is the previous one. So we leave that in there. That just means the previous term plus 11 for n greater than or equal to 2. So this is your recursive formula. Find a of 41. Well, if I was going to use the recursive formula I just wrote, I would have to go through and find A1, A2, A3, A40, A39, all of those in order to do that, right? Well, I don't want to do that. So that's the benefit of the explicit formula. So the explicit formula, which is right here, says I'm going to say, all right, AN equals A1, which is -12, plus 11, that's my D value, times n minus 1. So then, if I want to find A41, I'll say -12 plus 11 times 41 minus 1, which gives me -12 plus 11 times 40, and you will get an answer of 428. A41 equals 428. All right, and then for C, probably should have put C in front of B, but that's okay. What is the explicit formula? We kind of already wrote that right here. That is your answer for C. Negative 12 plus 11 times n minus 1. Okay? Moving on to example 3. What is the 21st term of the arithmetic sequence 11, 4, negative 3, etc.? So, of course, the first thing you need to do is find your D value. So D is going to be 4 minus 11, which is a negative 7. Or you could do negative 3 minus 4, which is a negative 7. But either way you do it, you get D as negative 7. And so then you're going to say A to the n. Just write your explicit equation. So A to the n equals A to the 1 plus D times n minus 1. There's our standard form. And now we can plug in what we know. So A to the 21 equals A to the 1, which is 11, minus 7, which is D, times 21 minus 1, which is 11 minus 7 times 20, which gives me negative 129. Okay, example 4. For the sequence below, write an explicit formula and find the 20th term. You do not have to find the middle terms. Okay, so this sequence is in recursive form. And so we need to turn that into explicit. And so remember, explicit is this form. A to the n equals A1 plus D times n minus 1. So what we have to do is we need to find our D value. So of course we know that our D value is 4. And so then the explicit form would be A to the n equals A1, which is 3, plus 4 times n minus 1. And there is the explicit form of this sequence. And then the next question says find the 20th term. So we're going to do A to the 20th equals 3 plus 4 times 20 minus 1, which means 3 plus 4 times 19. And you put that in and you get 79. All right, think about this. Are the following sequences arithmetic? Find A10 for each of the sequences without finding the middle terms. Okay, so for number 1, the first question is, are they arithmetic? And that means, is there, basically when it says that, remember, we're saying, is there a common difference? Adding or subtracting. That's what we're looking at. And if you play with your calculator and those numbers a little bit, you can see there is no common difference. No common difference here. So therefore, not arithmetic. But let's see if we can find A10 anyhow. So if you do a little dividing there and you do 240, 729, sorry, okay. Anyhow, if you divide by 3, you know, if you do 729 divided by 243, you get 3. And you do 243 divided by 81, you get 3. And so what we're doing here is we could say we're dividing by 3, or we're multiplying by 1/3. Okay, that's the relationship between those numbers. So that means what we're really doing here is we are doing a little precursor to get to our geometric sequences. And so if you don't catch this, you know, you will when we get into it more. But anyhow, we could write the equation then A to the n is going to be the first one, 729, times this common factor times n minus 1. So this is very similar, of course, to this, except for this is when we are adding and subtracting. This is arithmetic. This is going to be a geometric sequence when we're multiplying. And so we're going to say, what do we want to find? Find a to the 10. So we'll say 729 times 1/3 to the 10 minus 1, which is, sticking that in your calculator, you are going to get 0.037037, which also will simplify to the fraction 1/27, which is a better answer. So let's see, number 2. Again, this is not arithmetic, and we know that. Look at there, the signs change. We have positive, negative, positive, negative. There's no way it could be arithmetic. So what are we doing? Well, each time we're multiplying by -4. So that means we'll say a to the n equals a to the 1, which is 1, times -4 to the n minus 1. So finding a to the 10, we're going to go 1 times -4 to the 10 minus 1. And that is -362,144. And there's a to the 10. Okay, which brings us to geometric sequences. And a geometric sequence is any sequence whose successive terms have a common ratio r. So this is going to be multiply or divide. How do we find r? We can do right term divided by left term. Or we could think of it as this way, new term divided by old term. Here's your two formulas. We've already used this one. And here's your recursive. Notice that this is an exponential form. Okay, so example 5. Given this sequence, T1 is 4 and Tn is 6 times the previous one for n greater than 1. Find the first 4 terms of the sequence. So looking at this and comparing it to, where is it, right there, you can see, here's your r times the previous. We changed the order a little bit, but that's okay. R is 6. R times the previous. So find the first 4 terms. Well, T1 is 4. T2 is 6 times the previous, which is 4, and we get 24. T3 is 6 times the previous, which is 24, and we get 144. T4 is 6 times the previous, and we get 864. So these would be the first 4 terms, 4, 24, 144, 864. Write an explicit formula for the sequence. Well, our explicit formula is going to be Tn equals the first term times r to the n minus 1. And so we can say Tn equals, my first term is 4 times r, which is 6 to the n minus 1. And there is the explicit formula. Okay, example 6. Write a recursive formula. So we want recursive for the sequence 50, 25, 12.5, 6.25. And so the first thing we want to do is we want to find r. Well, you're going to do 25 divided by 50, which is the same as 12.5 divided by 25, which is the same as 6.25 divided by 12.5. It doesn't matter which one you do, you're going to get r as 1/2. And so the recursive form is when I say a1 is 50, and a to the n is the previous one times r, 1/2, for n greater than 1. And if you prefer, you can write 1/2 times a to the n minus 1. Exact same thing, doesn't matter. And there you go. That's the end.